installation of an IoT solution on Microsoft Azure. In this video, I'm going to demonstrate how we can connect a ReplicANT synthetic environment to Azure's infrastructure to store and visualize data of a production process. In addition, we're going to create an Azure function to generate additional information that is based on this data. The ReplicANT 3D model and every file pertaining to this demo will be available for download at replicant.ant-automation.com. On one hand, we have the synthetic environment, which is composed of the physical simulation and the control program simulation. In this example, we'll use ReplicANT's workflows that will initiate the production processes. On the other hand, we'll also be relying on Azure's infrastructure. To connect the production data to the cloud, we'll use Azure's IoT Hub. These messages will be processed by Azure's time series insight, which stores them in a storage account. The data then can be visualized in the web portal. Utilizing PowerShell script, we deploy the structure in Azure. Initially, it is going to request the requirements, which are ReplicANT Studio and Azure's modules for PowerShell. Then, it's going to ask if we're already logged in Azure. Next, it's going to ask for the location in which the services will be deployed. Lastly, it's going to ask what we want to name the resource group in which it will deploy the infrastructure. Each step of this script is deployed in one of the services that we saw in the presentation. Once it's finished, we can go to the Azure portal and make sure that the services were deployed within this resource group, which we named ReplicANT Demo. Next, we start up the synthetic environment so that it can start generating data that it'll send to the IoT Hub. With the synthetic environment running, we can switch back to the script of the simulation and activate the workflows, which are our control systems. If we go to the Time Series Insights portal, we can visualize the events that are being sent from the plant. We now search for and select an analog variable so we can visualize its curve. We go to our model view and create a new type of digital variable that we will be using to visualize the positive flanks and negative flanks of our digital variables. Then we assign it to one of our digital variables. Coming back to the curve, we select the modified digital variable with the new type digital signal. Any improvement to the production process has to be started by analyzing the time it takes to complete a cycle. To do this, we have to define how the period of the line is measured. We can use a signal that indicates when the pill bar reaches the home position. In the signal graph, we can see the positive flank and measure the time it takes for each pill bar to reach the home position. This will be how we measure the time of each cycle. To calculate it, we are going to implement and deploy one of Azure's functions. This function receives the messages from the IoT Hub, processes the pill bar composition signal, and writes the calculated time as a new message in the Event Hub, which will be another source of data for our time series insights. As we can see, our function's source code is quite simple. Now we're going to publish it. We open the Publication Assistant of Visual Studio, and we create a new publication profile. The Publication Assistant is going to ask where we want to deploy our function. We're going to choose the same location as the rest of the services in the resource group. To be able to publish it, we have to utilize the same connection string that we used to connect to the services. Once it's configured, we're ready to publish it. At this moment, the function is deployed in Azure's infrastructure. Once it's finished, we can go to the resource group to see our function together with the rest of the assets. If we go to time series insights and search for the new trend line, we can visualize its value. Changing the interpolation type, we are able to visualize the values that are between 28 and 32 seconds. This curve is being calculated within Azure's infrastructure. This is the conclusion of our demo. Thank you.